In late 1944, the Allies were winning the war, and still on the edge of losing it. Not to German armies, to logistics. They had tanks, planes, and men pouring across France. What they didn't have was a way to feed that advance. Every mile forward burned fuel faster than it could be delivered. Trucks kept moving, but the math was turning brutal. More fuel was spent hauling fuel than reaching the front. The faster victory came, the closer collapse followed. The solution wasn't smarter planning or better technology. It was something most engineers hated: loud, ugly, built fast, and never meant to last. By every peacetime standard, it was a mistake. And yet this mistake carried an army into Germany and kept the war from stalling just miles from the finish line. If you want to understand how wars are really won not by weapons, but by systems, make sure you're subscribed. By the summer of 1944, the Allied war machine looked ensammada. German defenses in Normandy had collapsed. Paris was liberated. Armies were advancing faster than planners had dared to predict. On maps, the arrows pointed confidently east, toward Germany, but behind those arrows a quadrilateral momentum. They move on fuel, ammunition, food, spare parts, and time. Every division advancing across France consumes staggering quantities of material. Tanks burned fuel even when idle. Artillery devoured ammunition at industrial scale, medical supplies, and replacements. Trucks were flexible. Trucks could bypass damaged infrastructure. Trucks had already proven themselves in North Africa and Italy. And above all, trucks felt modern. They fit the image of a mechanized 20th century army. Railways, by contrast, seemed slow, fragile, and outdated. A relic of 19th century warfare, that belief would almost cost the Allies the war. As the front raced eastward, supply distances exploded. What had been short hauls from Normandy beaches became journeys of hundreds of miles. Every truck sent forward needed fuel, tires, maintenance, drivers, mechanics, and spare parts. Worse still, trucks burned the very resource they were delivering. Fuel was being consumed simply to move fuel. At peak effort, the massive truck convoy system, later celebrated as the Red Ball Express, delivered impressive tonnage. Thousands of vehicles moved day and night. Drivers worked to exhaustion. Maintenance was deferred. Accidents mounted. Yet even at its best, the system could not meet demand. The faster the armies advanced, each success at the front made the logistics problem worse. Victory was stretching the supply system toward breaking point. This was not a failure of bravery or organization, it was a failure of scale. Trucks were excellent at short distances and flexible deliveries. An army that outran its supplies did not gain advantage. It stalled, or worse, it became vulnerable. By late August and early September, the symptoms were undeniable. Units began rationing fuel. Artillery fire was restricted. Armored formations slowed or stopped entirely, not because they had been defeated. Operational plans were rewritten around supply availability rather than battlefield opportunity. The Allies were winning battles while quietly losing the logistics war. The uncomfortable truth was that modern warfare had not escaped the laws of physics or economics. Much still mattered. Rail transport offered an entirely different equation. One locomotive pulling a long freight train could move the equivalent of hundreds of truckloads in a single trip. Trains required fewer crews per ton delivered. They could operate continuously, most importantly, freeing precious fuel for combat vehicles. On paper, railways were the obvious solution. In reality, they seemed unusable. Before D-Day, Allied bombing had deliberately shattered the European rail network. Bridges were destroyed. Marshalling yards were cratered. Rolling stock was damaged, seized or sabotaged by retreating German forces. The invasion succeeded in part because railways had been neutralized. The Allies controlled thousands of miles of track stretching across France and into Belgium, but had almost nothing to run on it. Captured locomotives were unreliable, incompatible, or deliberately damaged. British engines did not fit contemplated clearances. Building new locomotives in Leningrad. Skilled labor was scarce. Time was gone. This was the moment when the comfortable assumptions of peacetime engineering collapsed. There was no opportunity for elegant solutions, no room for refinement, longevity, or optimization. The war demanded something far less respectable and far more dangerous to traditional thinking: sufficiency. The real problem was not how to build the best locomotive. It was how to move enough supplies, fast enough, with whatever worked. The war did not reward perfection, it punished delay. The Allies faced a brutal choice: slow the advance and give Germany time to recover, reorganize and fortify, or abandon cherished engineering principles and solve the supply crisis immediately. The belief that modern war could be sustained on trucks alone had failed. What came next would feel like a step backward in technology but a leap forward in survival, because the solution to a 20th century war was about to arrive on steel rails, pulled by a machine no one admired and few respected. By early September 1944, the Allies understood the problem. Understanding it did not mean they could solve it. Europe was not short on railways. France alone possessed one of the densest rail networks in the world. Lines stretched from ports to industrial centers, from cities to rural depots, from borders to borders. Rail could carry the tonnage. Trucks never could. On the ground, rail was a graveyard. Allied bombing before D-Day had done exactly what it was designed to do. Bridges lay twisted in rivers, marshalling yards were cratered beyond recognition. Switching stations were reduced to fields of debris. Signals were gone. The rail network had been neutralized with ruthless efficiency. Now the Allies owned it. What they did not own was the ability to use it. The Germans, retreating under pressure, had completed the destruction. Locomotives were hauled east when possible. Those that could not be moved were sabotaged, berries smashed, boilers cracked. Rolling stock left behind was often unusable by design. The tracks existed, the trains did not. This created a uniquely cruel problem. Railways could not be rebuilt gradually like roads. A road could carry trucks as soon as it was passable. A railway required a complete system. Track locomotives without rolling stock were useless. Rolling stock without crews, fuel, water, maintenance facilities, and schedules was useless. Rail was either operational or it was nothing. Military planners explored every option and watched them collapse one by one. Captured German locomotives were the first idea and the fastest to die. Each required mechanics trained on that specific class. Many were built to German loading gauges, weight distributions, and maintenance standards that did not translate well to damaged French infrastructure. Even if they could be repaired, they would become logistical liabilities. A breakdown in the wrong place could immobilize an entire line while waiting for the correct part or the right mechanic. In a war defined by speed, complexity was lethal. British locomotives were the next hope. Britain had engines. Britain had crews. Britain had experience running railways under wartime conditions. British locomotives were built for British loading gauges. They were taller, wider, and heavier in the wrong places. French tunnels, bridges, and track beds could not accommodate them safely. Weight distribution stressed temporary bridges. Clearances failed. Modification did so under restrictions. They were not a scaleless solution. Building locomotives in liberated Europe was dismissed almost immediately. Factories had been bombed or dismantled. Power was unreliable. Skilled labor was scattered or dead. Sharing locomotive production would take months, possibly years. The war would be decided long before the first engine rolled off a European assembly line. The war had reached a moment where every traditional answer failed. The infrastructure existed but was broken. The technology existed but was incompatible. The expertise existed but was fragmented. The industrial capacity existed but not where the war was being fought. The Allies were facing a paradox of their own making. To win the invasion, they had destroyed the very system required to sustain it. This was the point where peacetime logic collapsed entirely. In civilian railway engineering, locomotives were designed to last decades. Durability mattered. Refinement mattered. Efficiency over long service life, 40 or 50 years of operation. Maintenance was meticulous. Crews were highly trained. Standards were high. None of that mattered anymore. The war did not require locomotives that would still be running in 1980. It required locomotives that could be running in 1944. What mattered was not elegance, but speed, not excellence, but sufficiency. The problem was reframed in brutally simple terms. How fast could a functioning railway system be placed behind advancing armies, using whatever would work regardless of tradition or reputation? The answer did not come from the battlefield. It came from factories thousands of miles away. American planners had anticipated its moment years earlier. They understood that European railways would be wrecked by bombing. They understood that captured equipment would be unreliable. They understood that rebuilding industry on the continent would take too long. So they made a decision that ran against every instinct of traditional engineering. They would not adapt European railways to existing American locomotives. They would adapt American locomotives to Europe. This meant abandoning the idea of building the best locomotive. Instead, they would build a single standardized machine designed specifically for Oyer. It would tolerate damaged track. It would burn fuel available locally. It would be simple enough to maintain with basic tools. It would be cheap enough to build in enormous numbers. And it would be expendable. The locomotive would not be a long-term investment. It would be a consumable. This concept was deeply uncomfortable. Engineers are trained to open minds, refine and perfect. Designing something to be disposable felt like professional heresy. But war does not reward pride. It rewards outcomes. The design requirements reflected this shift in thinking. Manufacturing speed would matter more than durability. Standardization would matter more than approximation. Crews would be trained quickly, not perfectly. Maintenance would be simplified, not elegant. The goal was not to build a masterpiece. The goal was to overwhelm a logistical problem with industrial output. Factories in the United States were already producing aircraft, tanks, ships, trucks, and ammunition at unprecedented rates. Locomotives would simply join the flow. Designs would be frozen, variations eliminated. 3 major manufacturers would build identical machines to identical specifications, ensuring parts compatibility across the entire fleet, partially disassembled to fit into cargo holds. Assembly teams would accompany them. Spare parts would travel with them. Manuals would be standardized. Everything required to operate a railway system would move together as a single package. The Allies were not planning to capture Europe's railways. They were planning to bring their own. This decision marked a turning point. It was the moment when the logistics crisis stopped being a question of execution. The war would not be saved by clever routing or heroic driving. It would be saved by something far less glamorous, a machine designed to be built quickly, used hard, and discarded without regret. In the next phase of the war, that machine would finally appear, and it would look nothing like the solution anyone expected. The decision to build a disposable locomotive did not feel bold at the time. It felt wrong. In peacetime, locomotive design was a discipline obsessed with endurance. Railroads invested millions into machines expected to operate for 40 or 50 years. Frames were forged, not cast. Boilers were riveted by skilled crews, not welded quickly. Bearings were refined, tolerances tight, finishes polished. A locomotive was not just a machine. It was an asset meant to earn its keep for decades. Every instinct of traditional engineering rejected the idea of building something crude on purpose. But war had changed the definition of success. It was how to build enough locomotives fast enough to matter before the front outran its supplies completely. The timeline was measured in weeks, not decades. A perfect engine delivered too late was worthless. A flawed engine delivered immediately could decide the war. This forced a brutal inversion. Of Priman was abandoned. Ease of manufacture became paramount. The new locomotive would be designed backward from the battlefield, not forward from the factory floor. It had to fit European loading gauges, which were smaller than American standards. It had to operate on damaged track and temporary bridges. It had to tolerate poor coal quality. It had to be simple enough that crews could be trained in days, not years, and above all, it had to be producible at industrial scale without disrupting other war production. That last requirement mattered more than anything else. American industry in 1942 and 1943 was already under extreme strain. Shipyards launched vessels at unprecedented rates. Tank and truck factories filled entire cities. Locomotive manufacturing could not be allowed to consume skilled labor, specialized tooling, or long production cycles. So the design was simplified relentlessly. Forged steel frames were replaced with cast steel. It could be done using molds rather than long forging processes. The result was heavier and less elegant, but it could be produced in weeks instead of months. Riveted boilers were replaced with welded construction. Welding saved time, saved labor, and reduced the number of specialized trays required. The boiler might not last 40 years. It needed to survive the war. Bearing systems were simplified. Tolerances were loosened. The result was noise, vibration, and rough operation. Crews would feel every mile, but simplified bearings could be produced quickly, replaced easily, and maintained with basic tools. Finishing work was minimized. Paint was functional. Cab interiors were Spartan. Crew comfort was sacrificed without hesitation. Every design choice sent the same message: speed over elegance, quantity over perfection, suction over pride. Perhaps the most radical decision was standardization. Instead of allowing manufacturing, 3 major locomotive builders would produce the exact same machine to the exact same specifications. Parts from one factory had to fit locomotives from the others without modification. Variations were eliminated. Customization was forbidden. This was deeply unnatural to an industry built on incremental refinement. A standardized fleet meant spare parts could be stockpiled efficiently. Mechanics trained on one locomotive could service any other. Maintenance facilities did not need to specialize. Breakdowns became manageable rather than catastrophic. The locomotive ceased to be a unique machine and became a system component. They were trained to operate a standardized tool. Manuals were simplified. Procedures were standardized. The goal was operational competence, not mastery. From an engineering perspective, from a military perspective, it was exactly right. The locomotive was not meant to survive peacetime scrutiny. It was meant to survive wartime peacetime scrutiny. Limited maintenance windows, improvised repairs, continuous operation. These conditions would destroy a refined machine. They favored something crude, forgiving, and replaceable. Critics were not silent. Railway engineers questioned the durability of cast frames. Maintenance crews complained about noise and vibration. Operators mocked the appearance. Nicknames reflected disdain rather than admiration. This was not a machine anyone loved, but none of those criticisms mattered, because the design had solved the only problem that mattered: how to put rail transport back into operation fast enough to sustain an advancing army. Production ramped aggressively. Factories adjusted. Altitude climbed. Locomotives were built not in small batches, but in streams. They were shipped across the Atlantic, partially disassembled, packed into cargo holds alongside spare parts. Assembly teams followed them. Uniformly, to create a functioning railway, followed them. The Allies were no longer waiting for Europe to recover its railways. They were importing an entire railway system. This approach reflected a deeper truth about American wartime strategy. The United States did not seek a railway system through perfection. Where others omit, it standardized. Where others refined, it multiplied. Where others hesitated, it produced. The locomotive embodied that philosophy. It was not designed to impress engineers. It was designed to crush a logistical bottleneck. The real gamble was not whether the machine would perform well. It was whether it would perform well enough, soon enough, in sufficient numbers. Everything else was secondary. As these engines accumulated in Britain, preserved and waiting, the decision moved from theory to inevitability. Ports expanded, assembly teams prepared, railway operating units trained for deployment. When the time came to deploy them on the continent, the war would enter a new phase. not defined by faster tanks or better tactics, defined by whether this deliberately crude machine could do the one thing it was built for: carry an army forward when everything else had failed. In the next act, that question would be answered on the shattered railways of France, when the locomotives finally began to appear on the continent in early September 1944. No one mistook them for something special. They looked wrong by European standards. They were squat and inelegant. The lines were blunt. The fittings were crude. Weld seams were visible where rivets should have been. Cast steel replaced carefully forged components. There was no polish, no ornamentation, no sense of pride in craftsmanship. These were not machines designed to be admired. They were machines designed to exist. Railwaymen noticed immediately. European engineers, raised on traditions of refinement and longevity, saw them as temporary contraptions. British crews who had operated them during the build-up to D-Day had already given them unflattering nicknames. They were loud, they rattled, they vibrated. Bearings clattered under load. Cabs offered little protection from weather. Compared to pre-war locomotives, they felt unfinished. They were in every visible way crude. This was not accidental. The locomotive had been designed with one mission and one mission only: move mass across broken railways under wartime conditions. Everything else had been sacrificed to that mission. It was built quickly, not beautifully. It was built to tolerate abuse, not to inspire confidence. The war did not need elegance. Once assembled and tested, the engines were pushed immediately into service. There was no ceremonial handover, no press coverage, no public recognition. They were handed to railway operating units, coupled to long strings of freight cars, and sent forward along repaired lines toward the front. On damaged French railways, the crude locomotives worked. They crossed temporary bridges that would have been unsafe for heavier, more refined engines. Their weight was spread across multiple driving wheels, reducing stress on compromised track beds. Their simple controls allowed crews with minimal training to operate them effectively. Their tolerance for vibration and imperfect alignment kept them moving where sophisticated machines would have failed. They were not fast, they were not smooth, but they moved. Each train hauled loads that drove truck convoys, ammunition, fuel, food, spare parts, engineering equipment. Entire divisions depended on what these locomotives pulled behind them. One engine could move what required hundreds of truck trips, and it could do so using coal sorts locally, freeing gasoline for tanks and vehicles at the front. The contrast with truck logistics was immediate and unforgiving. Trucks were still necessary. They handled short hauls. They moved supplies from railheads to high-manned units. But the long, grinding movement of bulk materials shifted decisively to rail. The crude locomotives changed the math as more engines arrived and more rail lines were repaired. Supply capacity surged. What had been a desperate shot in August began to ease by October. Fuel shortages that had immobilized armored units diminished. Artillery units fired without rationing. Offensive plans were no longer constrained primarily by supply availability. The armies began moving again. This was not a sudden miracle. It was a gradual transformation driven by volume. 50 locomotives became 100, 100 became 300. Each railroading rail line reduced pressure on truck convoys. The system scaled because it had been designed to scale. Standardization proved decisive. A breakdown no longer meant chaos. Parts were interchangeable. Crews trained on one engine could operate another without hesitation. Maintenance schedules were predictable. Fitties did not need to specialize. The fleet behaved as a single organism. German railway logistics, by contrast, suffered from the opposite condition. German forces relied on a patchwork of locomotive types, inherited from across, occupied parts, and trained personnel. As factories were bombed and supply chains disrupted, maintenance collapsed. Engines sat idle waiting for components that never arrived. Skilled mechanics became irreplaceable bottlenecks. The Germans had OMT for excellence in peacetime. The Americans had OMT for resilience in war. The difference was visible in operation outcomes. As autumn turned to winter, the crude locomotives continued working, Cold weather exposed, precision systems failed. Contours froze, the crude engines tolerated these conditions better. Their simple systems were forgiven. Steam heat prevented freezing. Basic bearings continued operating where complex ones ceased. Crews suffered. Comfort was minimal, conditions were harsh, but the trains ran behind the front. A logistical machine had come alive. Railway operating battalions coordinated movements. Repair crews advanced behind combat units. Damaged track was restored rapidly. Temporary bridges were reinforced. Supply flows stabilized at levels that would have been impossible just weeks earlier. The war entered a new phase. German planners had expected the Allied advance to stall. History supported that expectation, armies outrunning their logistics. Defensive lines were rebuilt. Time favored the defender. This time, the pause never came. By November 1944, the rail system behind Allied lines was moving hundreds of thousands of tons of freight, even accounting for inefficiencies, maintenance, downtime, and infrastructure limitations. Rail transport had surpassed the maximum capacity trucks had ever achieved. The Allies did not solve logistics through tactical brilliance or operational genius. They solved it by flooding the problem with capacity. The locomotive that no one admired had become indispensable. It was never intended to be a masterpiece. It was intended to be sufficient, and sufficiency applied at industrial scale. As Allied forces approached Germany's borders, the crude locomotives followed. They operated on newly repaired lines through Belgium and Luxembourg. They crossed into Germany itself as railways were restored behind advancing units. They hauled the supplies that sustained the final offensives. They carried an army into Germany. In the next act, the consequences of this logistical transformation would become undeniable, not in theory, but in the final battles of the war. By late 1944, the effect of the rail transformation could no longer be hidden behind numbers on planning tables. It showed itself on the battlefield. Only weeks earlier, entire Allied formations had been forced to pause, not because of enemy resistance, but because fuel and ammunition could not reach them. Armored units sat idle. Artillery fire was rationed. Offensive momentum slowed at the worst possible moment, just short of Germany's borders. Now those constraints began to vanish. Supply trains rolled steadily from the ports and rear depots toward forward railheads. Ammunition stocks grew instead of shrinking. Fuel dumps filled instead of emptying. The front stopped waiting for supplies. This reversal changed everything. Operations that had been impossible in September became routine by November. Commanders no longer planned around scarcity, they planned around opportunity. When resistance stiffened, fire could be concentrated. The war regained its momentum. Not through better tactics, but through reliable logistics. During the height of the truck-based supply crisis, every decision carried a hidden cost. Advancing one unit meant starving another. Supporting one offensive meant delaying others. Supply was a zero-sum game. Rail changed that equation. It introduced scale. Trucks did not disappear. They were freed. Instead of grinding across hundreds of miles from the beaches, trucks shifted to shorter, more efficient rolls. Port a railhead. Railhead to appant. To coal movement instead of strategic hauling. This reduced wear, saved fuel, and restored flexibility. The impact reached beyond logistics officers and supply depots. It reshaped operational tempo. In October, Allied armies resumed sustained offensive operations. In November, they pushed toward Germany's western defenses with growing confidence. Ammunition shortages that had once dictated artillery fire plans faded into memory. Fuel availability allowed armored formations. German planners had expected the Allies to slow, regroup, and consolidate. History suggested that advances of this scale required pauses. Instead, the Allies kept coming. Supply lines that should have snapped held firm. German countermeasures targeted truck convoys, bridges, and forward depots. The backbone of the supply system now lay beyond easy reach, protected by distance and Allied air superiority. Rail lines were harder to interdict than convoys. Temporary disruptions were repaired quickly. Volume absorbed losses. When winter arrived, the advantage became even clearer. Cold weather strained every system, roads deteriorated, veal thickened, but rail operations continued. Steam locomotives thrived in cold conditions. Their systems resisted freezing. Their simplicity reduced failure rates. They operated day and night through rain, snow, and darkness. This resilience mattered when the war reached one of its most dangerous moments. In December 1944, German forces launched a surprise offensive in the Ardennes. The attack aimed to exploit perceived Allied supply weaknesses, capture fuel depots based on an outdated assumption that Allied logistics remained fragile. The assumption was wrong. As fighting intensified, Allied commanders shifted forces rapidly. Troops, ammunition, fuel, and equipment flowed toward threatened sectors. Railways carried the bulk tonnage. Trucks handled the final movements. The system flexed instead of collapsing. The Ardennes fighting exposed a critical truth. Les Donnettes did not merely sustain operations. When German units broke through in places, they captured forward supplies and disrupted local networks. But they could not sever the core rail system behind Allied lines. The depth and redundancy of the network absorbed the shock. Losses were replaced, gaps were filled, counterattacks were supplied. A German offensive had failed. Allied forces regained the initiative with overwhelming logistical support behind them. The same pattern repeated during the final offensives, as preparations reinforced cross-continental levels. Artillery concentrations required mountains of ammunition. When Allied forces crossed major rivers and pushed into the heart of Germany, they did so with supply streams that matched their ambition. The old fear of outrunning logistics no longer applied. Railheads moved forward. Repair teams followed close behind combat units. The system advanced with the armies it supported. Germany had fought a war built on operational brilliance and tactical excellence. It struggled with sustained industrial warfare. Its logistics depended on complex systems vulnerable to disruption. When those systems were damaged, recovery was slow and incomplete. They accepted inefficiency at the machine level in exchange for resilience at the system level. The result was a supply network that could be damaged without collapsing and expanded without redesign. The war's final months were not defined by dramatic supply crises or desperate pauses. The outcome was no longer in doubt. The crude locomotives did not win battles. They did something more important. They ensured battles could be fought without interruption. They removed scarcity as a strategic constraint. They allowed commanders to think offensively instead of defensively. In total war, this distinction mattered more than any individual weapon. By the time Allied forces reached deep into Germany, the logistical transformation that had begun quietly months earlier had reshaped the entire campaign. What had once been a fragile advance dependent on heroic effort had become an industrial process. Supplies moved because the system demanded it. The war was being decided not by moments of brilliance, but by the absence of failure. In the final act, the broader meaning of this transformation would become clear, not just for World War II, but for how modern wars are won, misunderstood, and remembered. From the German perspective, the Allied advance in late 1944 made no sense. Not tactically, logistically. German planners were not ignorant of logistics. On the contrary, Germany entered the war with one of the most sophisticated railway systems in the world. Its rail network was dense, locomotives, built to exacting standards. German railway engineering emphasized precision, durability, and efficiency. In peacetime, it was a model admired across Europe that sophistication became a liability in total war. German logistics doctrine assumed railways would remain intact enough to support operation. It assumed time existed to repair, optimize, and maintain complex systems. Those assumptions collapsed under Allied bombing. As factories were damaged and supply chains fragmented, locomotives sat idle, waiting for specific parts. Repairs required skilled mechanics. The German system was unfit for excellence, not resilience. When German intelligence assessed Allied logistics in August and September 1944, analysts expected the Allies to face the same limitations Germany did. Railways destroyed, rolling stock scarce. Supply lines stretched beyond stationality. Armies that advanced too far, too fast, almost always paused. Logistics imposed limits. Time favored the defender. German planners expected those limits to reassert themselves west of the Rhine. They never fully understood what the Allies had done differently. German intelligence reports noted increased Allied supply movements. What they saw looked improvised, crude, inefficient. They assumed such systems could not sustain prolonged operations at scale. They mistook simplicity for weakness. The Americans had not attempted to preserve elegance. They had abandoned it, instead of relying on a patchwork of captured equipment and refined machines. They had imposed uniformity, standard training. Where Germany had complexity, the Allies had redundancy. This difference mattered most when things went wrong. When a German locomotive failed, it often failed completely. Repairs required the right part, the right mechanic, the right conditions. When an Allied locomotive failed, it was swapped, patched, or bypassed. The Allies focused on system behavior. This mismatch became fatal in late 1944 and early 1945. During the Ardennes offensive, German strategy depended on disrupting Allied supply lines. Fuel shortages, cruel depots was essential. The plan assumed Allied logistics were as brittle as Germany's own. Allied rail infrastructure lay deeper and broader than expected. Temporary losses were replaced rapidly. Railheads shifted, supplies rerouted. The system bent without breaking. German forces captured forward dumps but could not reach the core of the supply network. The offensive failed not just because of Allied resistance, but because the Germans could not strangle Allied logistics the way they had hoped. As the war moved into Germany itself, the disparity grew sharper. German railways were in ruins. Bombing had destroyed bridges, yards, and factories. Repairs lagged rolling stock shortages. Fuel shortages compounded every problem. Meanwhile, Allied locomotives rolled forward onto German track with minimal modification. They tolerated damaged infrastructure. They required no specialized support unique to Germany. The Allies did not need German systems to function. They replaced them. This was the ultimate miscalculation. Germany had assumed that destroying infrastructure would level the playing field. It did not anticipate an enemy that would arrive with its own infrastructure, built elsewhere, designed to survive destruction rather than avoid it. The German approach to engineering emphasized mastery. The American approach to superior. In total war, sufficiency scales better. By the spring of 1945, the outcome was irreversible. Allied forces advanced with logistical backing. Germany could no longer match. The war had become a contest not of tactics or bravery, but of systems. Germany had built a machine that worked brilliantly when conditions were ideal. That difference decided the final campaign and the final act. The meaning of this choice becomes unavoidable, not just as a historical lesson, but as a warning about how wars are often remembered incorrectly. When Germany surrendered in May 1945, there were no victory parades for locomotives. No cameras followed supply trains. No medals were awarded to railway operating battalions. The public memory of victory focused on tanks crossing borders. Soldiers remembered through moments of drama and heroism. The machines that made those moments possible disappeared into the background. Across Europe, the crude locomotives kept working. They hauled occupation supplies, reconstruction materials, displaced civilians, and food into shattered cities. Many were sold rather than scrapped. The war ended long after the conditions they were designed for had passed. They outlived the conflict. They were never meant to survive. This quiet persistence revealed the deepest irony of the entire story. The machines built to be disposable were often more durable than expected. The machines built for perfection collapsed when perfection was no longer possible. It had been won by technology that could be delivered, repaired, and replaced at scale. This lesson is uncomfortable. It challenges the way wars are remembered and the way progress is imagined. It suggests that superiority does not always come from excellence. It often comes from availability. The Allies did not win because their locomotives were better. They won because their lightest were harder to break. The crude locomotive was not a secret weapon. It was visible, loud, and unimpressive. Its power came not from innovation but from acceptance. Acceptance that war punishes delay broadly, outperforms brilliance applied narrowly. Germany built systems that assumed stability. The Allies built systems that assumed chaos. In total war, the second assumption was correct. This is why the story of the crude locomotive rarely appears in popular histories. It lacks glamour. It lacks individual heroes. Its victories were cumulative, incremental, and relentless. And yet without it, the war might have stalled short of Germany's borders. Time might have shifted, defenses might have solidified. The cost in lives and months could have multiplied. Logistics does not create headlines. It creates inevitability. The crude locomotive embodied a philosophy that remains relevant long after World War II. In crises, systems designed for ideal conditions fail first. Systems designed for adequacy, simplicity beats refinement. Simplicity beats refinement. Avail beats opinov. This was the real engine of victory in Europe, not a tank, not a bomber, not a general, but a machine built fast, built rough, failure irrelevant. It carried an army into Germany not because it was admired, but because it worked, and when the war ended it faded quietly from memory, having done exactly what it was designed to do in war as in history. The most decisive tools are often the ones no one wants to celebrate. If this story changed how you think about World War II, leave a comment. History remembers battles, but wars are won somewhere else.